So this is the explanation, I guess, for FRQ review set number 11. This is the first question. So it asks, on the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So since we're already given the equation for the slope, all you have to do is find the points to that slope, or the points, yeah. So all you have to, you're given these points, and you just have to plug the coordinates to these points into the equation. So then this will be like this, and then I'm just going to do these, and I can show you the rest on my other paper. So then this would be like this. And then you would plug in 2, 0, 2. And then that equals that equal so then it would be like that, I guess. And then this is the answers, the rest of them. That's what the graph would look like. Okay, so the second question, 1b, says let y equal f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. So what you should do is, since you're given the equation for the slope right here, if you plug in 3 as your y and then 2 as your x, so this would be the point 3, 2. Plug in 3 as your y, 2 as your x, and you would get the slope of 9. So then, since you're given the slope, you can find the equation to this to be able to find f of 2.1. So if you make y minus y1 equals 9 times x minus x1, and solve for y, you get 9 x minus 2 minus 3. And then all you really have to do is put f of 2 minus 1, plug in not 2 minus 1, 2.1 in for x, and then equals 9 times 2.1 minus 2 minus 3, and you would end up with the answer of 3.9. There you go. And then 1c. Find the particular solution y equals f of x to the given differential equation with the initial condition. So, you can put this, since this is given in the very beginning, and then you can do separation of exponents. Yeah. So you just separate y and the x. So if you divide this by y squared, I'm just going to do this in one step, and then multiply by dx, you get 1 over y squared dy equals 1 over x minus 1 dx. And then to get rid of both the dy and the dx, you can integrate both sides, and then that'll get rid of that and that, and then you get negative 1 over y equals, and for this you just take the antiderivative of both of these equations, then you get natural log x minus 1 plus c. So ultimately c is what we're going to solve for, because once you have c, you have the rest of the equation that you need. Okay, so then you plug in the point you're given again. You plug in negative 1, and then you plug in 3. It's natural log of 2 minus 1 plus c. Then you get natural log of 1. Sorry about that, Mr. Major and other classmates. Yeah, I paused my video on accident and stopped it. So, natural log of 1 ultimately would be 0, and c equals negative 1/3. So then you plug this into this equation. Okay, sorry, I can't really do anything about that. I feel really bad. So I'm just gonna try and get this done. Negative 1 over y equals natural log of x minus 1 minus 1/3. And then you would want to multiply by y and divide by all of this, so you would get 1 over 1/3 minus natural log x minus 1, and that's the answer. Sorry about my dog, I can't do anything. So yeah, that's my thing, I guess.